Hello, hello. This is lecture two. Well, it's not really a lecture. It's like the video for lab exercise two of physics 111. Hello. Thank you so much for watching this. As you know, those of you who have already completed lab exercise two without watching a video, good job. It's designed that way. There's only one small question that's designed to sort of interact between this video and that lab exercise that's like absolutely necessary. And I just told you, just skip that part if you can't do it because you've already done the exercise without the video. However, this video is designed for anyone who wants to watch it. You want to see it and sort of get the inside skinny on how to do that lab exercise number two. I know that sometimes people who haven't done coding before, it hits sort of roadblocks right away and you're like, forget it, right? But stick with it. It's really worth it. Okay, hang in there. The key is to read the instructions and the syllabi and the different pieces of written stuff and email stuff. Do that carefully and you will not be off. Okay, everything will be good. And one more thing I should just mention. Some of you who like are typing in for the first time some code and it's not working, you're like frustrated. That's okay. We are learning all the time. And if you're not good at it right away, it may seem difficult. It may seem like it's completely opaque, whatever. But appearances, things are not always that they seem. For example, you may think I got a haircut, but I didn't, right? It's 100% just learning and working on it. When we, like, let's say with children, right? When we're teaching kids how to walk, and they take their first half step and then they fall on their butts, right? And they're 1 year old or however old. Do we go, you suck, give it up, don't try tall walking anymore? We go, yay, good job, yeah, take another one, right? That's how we learn coding. That's how we learn anything, really. And a lot of times we're like, this seems so difficult, I gotta stop now, and it's all over, I give up. Don't do that, all right? Be of good cheer. The course will be evaluated in such a way that that effort is what will be applauded, right? Yay, good job. Not a matter of you get the right answer or not. That's of secondary value. It's good if you get it, but if you don't, I don't mind. Make sense? All right, so let's go with it. Let me share my screen and remind you all on the syllabus what the situation is, right? If you haven't read the syllabus yet for the course, read it. You don't have to memorize everything, but you really need to know how this works, right? It's a 1-credit class and it fulfills a general education component, like a portion of it. And so as a result, you're using computers, which is such an important part of our lives, right? Hang on a second. I got to deal with the ringing phone. Nope, I don't have to deal with the phone. Anyway, here's the story. All right, let me go back to the sharing the screen here. All right, if you are looking at the syllabus, right, you're just learning how to do a computer program, right? There are charts and graphs and statistics and things like that. That's all part of science. And you're just having to do it on a computer, right? And so by the time you get through this, you'll be like that person if you don't have any coding experience yet, right? It's an introduction to computational techniques. It's designed to be able to get you by learning and figuring out how to do things with your efforts and so on to have that 21st century toolkit, just to start, right? At the end of a few months of walking, a person who's just learning how to walk isn't going to be able to go all the way to California, right? It's not going to happen. Well, if you're in California, then maybe you don't want to go to New York. But the bottom line is these are the steps. And once you have that basic information in, you're going to be able to go forward and do just fine. Okay, so the course components, the first 6 labs are going to be these assignments, right? About 6. And then the last project is sort of knitting together all the different pieces of what you've learned so far into a larger project. Again, the right answer is secondary. The actual doing of it is what matters, right? And of course, as we've said before, if you attend the recitations, your recitation professor, you're going to be set up much better for success. And the last part, do not forget this. You're going to see this in a moment in the video, right, where the trinket.io stuff. But this book, I'm going to be signing some reading for you in there. For those of you who would benefit from it, you should do this reading, and it'll be of great value to you. And I want you to make sure those things. So I just wanted to go over that and make sure that you understood. a lot of your questions will be answered by reading the material, okay? The syllabus, the lab exercises, things like that, all right? So don't worry, if something is like not working right, go back and take a look. And then if it still doesn't work right and you keep trying, you're playing with it, right? That's what you're trying to do. If it doesn't work, it's okay. Ask a professor, ask a recitation instructor, ask me, send me an email. Many of you already have. And that's 100% cool. Now, we may not be able to answer your exact question right away and fully correctly, but we will do our best. And the whole point is that you keep working at it, and eventually the success will come. At whatever level, it's good. All right? Okay, so with that in mind, let's go right over to the lab thing, and let's just go through that lab bit by bit and just piece by piece. All right, let's go back to the shared screen. Let me show you what many of you are experiencing or have experienced already. Okay, let's follow the instructions of the lab. What does the lab say? Well, we have to go to this thing called onlinepython.com, right? So you go to part 1 of the lab. I'm turning over to take a look and see, you read it, you run it, you execute it. So let me just type that in and I'll go onlinepython.com. All right, here I am. And here is 10 lines of code right there for you in the default, right? That's just what it's called. For those of you who don't know, the term default means if you don't do anything, what happens, right? In other words, if I haven't set any new things on there, I haven't changed any settings or anything like that on this computer or on this website for myself. So default, just right at the beginning, you type it in and these lines come in, right? And remember what happens if I type in this stuff now. If I just type run, following the instructions, right? It says enter the first number. Well, my first number, what was my first number on my thing? Oh, I got to enter the last digit of something or another. So I might type in 8, all right? And then I enter the second number. Notice I'm scrolling up to the next point here. The second number, oh, the last digit of something else. So I'll put that 5. And it says, bingo, look, it has the sum of 8 and 5 is 13. And the process is exited, it's done. So it ran the program. It basically, this is a tiny, very simple app. And what this app has done has taken 2 numbers that I have and turned it into a third number. Now, if I walk through this, this is what's happening. Okay, let me tell you what all of these lines mean, basically, to start with. And if you want further, deeper definitions, like I said, the Python for Everyone book is great. I'll show you that in a moment, and it's free. So that's something that you want to pay attention to. But here's the story with this, right? Each of these lines serves a purpose. These blank lines serve the purpose of spacing out the different things that we want to do so we can understand them and pay attention to where they are, okay? These spaces between the different characters help the program interpret what you're doing. Now, this is a very important point, okay? This term I've mentioned, I'm going to type in the word so you know, okay? You may have gotten some errors on this already. It's called syntax, all right? What is syntax? S-Y-N-T-A-X. That word syntax, right, means the spaces, the quotation marks, the parentheses, the letters, the characters, all the different ways that you do to communicate or to write your software. All right. This is what syntax is. And the vast majority of errors you get when you're doing computer programming is syntax errors, which means that you mistyped something, you did something different. So for example, if I just like do that, okay, and just didn't have that space there for some reason, okay, and I were to run it, oh, looks like it's going okay. All right. Yeah. So that space, the syntax from that space didn't matter. Okay, so that's good. That's good news. But what if I removed, accidentally didn't put that in? Okay, that one quotation, remember, it normally is there, right? Whoops, now it's produced 2 quotations. What if I just want 1 quotation mark? Oh, if I have 2 quotation marks, what's going to happen if I type this? Uh-oh, syntax error. And it goes right to this point. See this line here? It says, oh, look, on line 10, you have a problem, right? On line 10, you have a problem, this extra thing here. I don't want that. While scanning this literal thing, it gave me an error, an end of line. Okay, so I got to go back and fix this. I got to bring it back to 1. instead of 2. And then when I run it, it's working again, right? Oh, that messed up. What happened? Oh yeah, this is a different kind of error, right? This is a runtime error. And what happened was that when it asked me for a second number, I didn't give it. I just hit enter or return. I hit, said, and so it doesn't know what to do now because the next line is line 8, right? It's trying to pick up the thing, but it says invalid literal. In other words, I got nothing. There's nothing there. Literally, quite literally. Remember, this is syntax, right? Quite literally. There's nothing there for it to add. So we can't do it. Bummer. So that's an error on the runtime. So if I fix the syntax, let's see if I do it without making error in either the syntax or the runtime. This time I'm very careful to type in my second number. Bingo, it's done. It worked. The sum is 5 and 7 is 12. See how that goes? The syntax and runtime errors happen all the time. When you're typing on your phone and you're running an app, probably 90% of the time that whichever coder or whichever software developer developed that app was spending on creating the app was to solve errors. Okay, solve errors of all kinds, syntax errors, other kinds of errors, making sure that you can runtime errors don't happen. Those things are really key parts of advanced computing. So right now, when you're doing computing early on in this introductory aspect of things, these syntax errors will drive you nuts. You'll be like, wait, what do you mean there's a space that I shouldn't put in there? Wait, what do you mean there is a quotation mark that shouldn't be there, right? 90% of your problems when they don't work is going to be because of some silly thing like that. Now, that's frustrating, right? But think about how we human beings deal with stuff, right? When we process language and someone says the Easter Bunny or, the Columbus Day holiday or the first day of school, you kind of know what that means. But what if you say first the day of school? Or if you say first day of the school, you put the in the wrong direct position, that kind of still makes sense, right? But if you say first the day of school, well, that doesn't make sense anymore. Now, if I could understand a greater context, like we were having some sort of conversation about the first day of school, and you accidentally said first the day of school, I could figure that out, right? And then intellectually in my brain, I process what you really meant was the first day of school. But it could have been something else, right? The computer programming software stuff doesn't know the rest of that context. So if it says first the day of school, that might be the beginning of a sentence, right? First, the day of school where I go to will be the second day. Or, it becomes unclear. So when you're writing your computer programs, make sure that clarity is top of mind. And it may drive you nuts because you're like, come on, it's just a quotation mark. What's wrong with you, right? Sometimes the program will be able to say, oh, this is what you meant. But most of the time it won't. So be patient, okay? Go back and type things. When I say type this line exactly, type it exactly, right? Then if things get changed, you'll know why. Do not worry. This is part of the process. It can be frustrating, but like I said, your evaluation of yourself and your success in this program is not about getting the right answer as it is about figuring out how to do this process. That's what a lab class is about. Fair enough? Okay. This lab class, instead of pouring chemicals or, poking at preserved specimens, right, is taking this digital information and making it do what you want it to do. That's what this is about. So have that positive attitude going in, and let's go in and try to do some of these things. I'll just demonstrate the first part of this lab for you, and we'll see where it goes. Sound good? Okay, I won't demonstrate all of it, but I'll demonstrate some of it. And let's share the screen, and I'll show you all that again. All right, let's go back to the online Python. And if I can find where I was doing the lab exercise 02. Okay, so I go down to the section in part 1C, for example, and it says, in the line of this window, type this line of code exactly. All right, so I'm going to type that line of code exactly right here, like that. Okay, and then once I've done that, I will hit run one more time and let's see what happens. Well, let's put 5 and then the second number is 7 and look at the screen. It did it twice. So in other words, 10 and 11 did exactly the same thing. This and that is the same thing, but they're typed out differently. What does that mean? Well, it turns out that, there's more than one way to express something. If I say the word car in English, and then I say the word automobile in English, they mean basically the same thing. Like there's subtle differences, but in the end, it's the same. You get the same result. So this is the same thing. What's happening is that apparently this part, right, the sum of A and B in this curly brackets, is apparently the same as just A plus B in curly brackets. Isn't that cool? Yeah, it is. So this is sort of a way of saying what's going on in this program online Python that's causing you to write your program, this code here. Okay, let me break down for you what each of those lines mean. All right, pay attention to this because if you're not familiar with how code works, this is how code works. All right, and remember, this is not a computer science class, right, or a coding certification class. We are doing physics. We are learning this basic scientific computing techniques to later on do stuff that we would ordinarily do in a physics lab, right? I say ordinarily, but like I said before, this is a physics lab. We just need to know the tools. In the same way that if you were in a biology lab and you were poking at a specimen, you have to learn how to use that little pokey thing, right? This is the thing, how you do this. This is how you slice that. This is how you clip this and put it over there. This is what you're learning. This syntax, this recording, that's the stuff you're learning now, okay? So pay attention, all right? Really, really, it's worth it. I know. And if you want, go back through this again, all right? Watch this a second time so you know what it's doing. And then you'll be able to start taking those first steps if this is still confusing to you about what the programming is doing, okay? So let's just walk through the lines. Line 1 is a blank line. Line 2 is what's called a comment. You see this hashtag in front of all the rest of the words? That means that this doesn't get processed by the computer. You can type in stuff to remind yourself what it works, right? I can put my name up here. So for example, if on line 1, I decide to write, this is my physics 111 lab code or something like that, right? That's how you do it. And then the computer program doesn't get confused. It just does the stuff that's not in front of the hashtag. Does that make sense? I can do this anytime I want so that I can learn where everything is. So this is very important. So that's a hashtag means comment. All right. Now these terms, IDE, editor, compiler, interpreter, these are all different components of how you write code, the different pieces of a programming language that you can use to write your own apps. You don't have to worry about what they mean right now. They're just things that you can learn about in just a second. Okay, so or just a minute or next month or whatever. That's totally okay. Excuse me. I'm gonna drink a little bit of water here. Just to make sure that everything is clear. Refresh. Okay, here we go. The this next line, def, it means definition. Okay, so the code runner, the compiler it's called, will run through and say, okay, line 1 is blank, ignore it. Line 2 is a hashtag, is a comment. Okay, ignore that. Line 3 is a blank, ignore that too. Line 4, def, you are about to define something. Okay, this something is this sum function. So apparently what will happen is that if someone types sum and does the parentheses and the comma and two numbers, A and B, just right, then when it does that, it will return, it will show on the screen, A plus B. Make sense? That's what, okay, so now this def, this is defined what sum is. Good. Next step, all right? Remember, process this, all right? That's what's happening. Next thing, A. Well, if I want to add A and B, I want to know what A is, right? How do I find out what A is? Now here is a built-in function. Okay, the int means give me an integer. All right, integers are whole numbers. basically from 0, 1, 2, 3, 4, 5, 6 all the way up, and 0, -1, -2, -3 all the way down, right? In whole numbers. So I want the integer that if I type enter first number on the screen, if the computer types enter first number on the screen, then the user, you, the typing person, will input a number, right? Remember I had that runtime error a few moments ago? It's because I didn't enter a second number. So it didn't do anything. It said, no, I don't have a second number. I can't do B because B doesn't exist. But in this case, if I type in A as some number, like 5, it'll say, here, look down here. It says enter first number. And it says 5. I've typed in 5. So now it knows that A is 5. Then it does the same thing. As an input, enter the second number, and it'll give you integer of 7. Then, that's line 9, doesn't do anything. Line 10, print. This print function says, okay, if you have anything that's written in here, it will show it on the screen down here, right? So print F, that's like a piece of syntax that the print function needs to know where it's going. And then here's a single quote. The sum of A and B is the sum of A and B, close quote. Remember how there was a problem when I put in 2 quotes by accident, right? It won't work. It won't work because it's a syntax error. But see how this is working, okay? If I just type A here, then it'll put the letter A. But because I put it in curly brackets, it'll give this value of A, right? This value of A is known as a variable. I know, learning a lot of vocabulary. Don't worry about it. It'll slowly come to you. It's like if you're first learning a foreign language or something, right? So many words, but don't worry. It's coming to you. This variable A is expressed, the value of the variable A is expressed if you put it in the curly brackets, right? So in that case, since I typed in A equals 5, then it will show 5 here, and B equals 7, right? But if I just type the letter A, sum of A and B, then it'll write sum of A and B. It won't say actually 5 and 7, it'll say A and B. But because I put it in the curly brackets, it gives the numbers. And then this sum, A comma B, is this function, right? It goes up to this part where line 4 and line 5 says, oh, if I put A and B into those positions on this sum, then you have A plus B. So it knows that A's value is 5 and B's value is 7. So it adds 5 plus 7. It returns 5 plus 7, which is 12. But look at line 11. It's identical to line 10, except for what we did here. We just did this A plus B in the brackets. Apparently, that comes out with the same result as sum of A plus B. Isn't that cool? Yes, it is cool. Because apparently, this syntax is interchangeable. It knows that this is, if this is a car, then this is an automobile, right? It's basically the same, but it's using the math in a different way. It just typed it in differently. See, that's why we wound up with this. That's the 5-minute explanation, line by line, of what this particular code does, if that makes sense. Sounds a little complicated, doesn't it? Yes, it is a little bit. But remember, that's how we talk too. We human beings, we've been doing it for so long, we kind of forgotten, but that's how we process, right? The grammar, the punctuation, the words, the vocabulary, the syntax, all of that construction, it's all built in. And you know how some people can write really, really beautiful essays, and some people are really persuasive when they're talking and things like that? That is a result of how we use these basic tools and turn them into something, right? In this case, just addition. But that's how, for example, you tell the difference. If I'm a really experienced coder, that's make the difference between an app that you don't want to use and an app you do want to use, or an app that's really useful, I don't know, messaging, for example, and an app that's not useful, or say a game that you like to play, as opposed to a game it's like, I tried it once, it's no fun anymore, I'm done, right? So that is the syntax, and that's the very beginning. the first parts of what it means to be a coder. But remember, again, these code things are designed just to get us in the door. Your coding, all right, is not the key part of this lab. Your coding is so that you can do other stuff, right? Once you learn that, like how do you use tweezers? How do you use a pair of calipers? How do you use a scalpel? How do you use hydrochloric acid? Once you learn these things, then you can do things in the lab. That's what we're doing here. Make sense? Okay. All right. Again, feel free to go back and read it again if you want to, or watch this again so you get a sense of it. But if you don't worry about it. Okay. And then we'll go a little bit further. Now let's try some of this other stuff. In that same work that we were doing before, let's try to find some additional things to type in. Okay, so we did line 11. Now let's do line 12. Exactly the same, right? Remember, it says you got to do it exactly. If it doesn't work, it's probably because there's a syntax thing. Take a look and see if you've got any issues, right, with your syntax. Have you missed a parentheses? Did you put one too many quotation marks? Things like that. Okay, so that's directly typed in with all the proper spaces for all of those lines that I had before, right? Based on what I had typed in lab number 2. Now I'm going to hit run, see if I did it right. Maybe I have a syntax error. Maybe I don't. 4, my second number is 9. Wow, look at that. It's got all of it, right? Sum of 4 and 9 twice because we did it 2 times up here, but it also subtracted a minus b is -5. And then it multiplied a times b is 36. And then did it again, right? A divided by d is 0.44444, etc. And that's it. It worked. Yay! Right? That's nice. So that's how that part of the lab goes. And then you write about it and then you do other things because later on in the lab, what happens? Instead of just doing the 1 times 2 times 3 or the 1 times 2 or the 1 times 3 or the 2 plus 4 or things like that, it starts getting more complicated. And now that's the part where you can exercise what it means to do addition and subtraction, right? Here's the copy of the lab exercise. Your number, A, plus 6 times your number, B, minus the product of A plus B together, all divided by 2, right? That's an order of operations thing. Like, can you do just first? Do what is A, 9 times your number A. What's 6 times your number B? What's A and B multiplied together? And then you minus that from those other things. And then you divide all of it by 2, piece by piece by piece. Can you do it? I'll bet you can. But you break it down and do one thing at a time, or you do all these other things, right? And you take a screen grab of that code and you play with it. Show me what happens. Did you get it right? Be nice if you did. If you didn't, I don't care, right? Show me what happened though. Don't just go, I give up. I'm getting errors. Forget it, right? Don't worry about that. The other part is more important. Let's see, 9 times 6 is this, or 2 plus 4 is that, or how am I doing this? Can I break this up into line by line, or can I put it all together, right? That is the fun part to try. That's what I want you to try. That's the point of that part of the lab. Make sense? Okay, so let's look at the second part of the lab, and this should wrap up this video so you can get a sense of how to do it from here. Lab exercise 2. We're going to graph a scatter plot. We're going to go to a different lab. You see all this stuff here, right? That's a new kind of graphing. Now, this kind of plot, okay, this is a little bit more complicated, but it's still the same style of activity, right? You're not going to get an answer instantaneously, but you get to play with it. So I'm going to try that right now. I'm going to take that bit of code. I'm going to start plotting it in and typing it into my other stuff. So let me share my screen again. And then this time you can see what happens now, right? It's basically the same thing as we were doing before, but with more complexity. That's okay, right? Complexity is life. Well, our lives are complex, and that's good. All right, so here we are on this screen. And now in this section here, I'm going to put in that trinket.io/python3. Okay, it's going somewhere else? Sure. Let's leave the page. All right, so what does this say? Trinket.io, Python 3. And this is, again, the default screen. When it just shows up, what is it going to show me? Doesn't seem like much, does it? Okay. Oh, main.py. Well, what's here? If I reload it, it's connecting to the server, right? It's thinking about it. Let's see if we have anything there. Well, let me go over to the lab itself and see what it says. You see how we're going back and forth from one thing to the next, right? Go to this lab section here, lab exercise 02, doc. And what it says is, type these following lines of code exactly. Okay. I'm going to cut, paste those because it's convenient. Stop the share for that screen. Go on to the next screen, right? This is all stuff that you know how to do. This is stuff you do all the time in your computer usage, right? On your phone, you're going from one app to the next. That sort of thing happens all the time. So I'm going to paste it in here. Whoops, it went over there. I want to put it over here. So I click over here. There we go. And let's see what happens if I run it. Now, the run program here is this arrow, right? And the other one was a run button down at the bottom, but now this one is an arrow. What does it produce? Oh, look at that. It produced a plot. It's got these 4 points in it. What are the points? Well, x equals 1, y equals 2. That appears to be the first point right here, right? The next point is x equals 2, y equals 4. That's right there. And then the next one is x equals 3, y equals 6, and that's 3, 6. You see how that did it? I just wrote a tiny little program. It's only got a few lines, and I made a plot of 4 points. Isn't that cool? Yes, in this case, what has happened is this Python 3 software has allowed us to use this thing called matplotlib.pyplot. Okay, in other words, I know it sounds complicated, but what's happened is that this import thing is exactly as it sounds. When I'm typing my Python code, I'm telling it, okay, somebody else has already written a whole bunch of code, and they've got all these functions. They've got different names, x data, y data, plot, plt, whatever, right? And I would like to use them. I'd like to borrow them for now. So please import them, take them, and put them into your software so that you know that you can use it. See? So that's how this works. And I will keep demonstrating in the future other kinds of text, other kinds of code like this. But this is what you do. All right. And if you'll go, let's share the screen one more time on the lab, and we'll call it. Okay, so here's, let's see here. So if you're looking at this, notice the run button, right? The upper pointing triangle, what appears? Now go to this line on line 5 and type something different, right? And do other things. On the left window, type this. These are all different things you can put in, right? You're just adding new bits of stuff. And every single time, you're going to wind up with something a little bit different, right? Now, let me see if what happens here. I put line 5 of the left window. I've typed this happens. Let's see what happens, okay? Let's do that and just see. Did it work? Did it not work? Let's find out. Bum, ba-dum, bum, bum. Very exciting, right? Okay, let's do this. Trinket, I'm going to follow the exact same thing. On line 5 of the left window, type this. Type it there. So I think I have to do something like that. Let's see if it works. Uh-oh, I messed up. Something is wrong. Uh-oh. Let me see. Let me bring this back over here. What if I typed that? Maybe put it on line 9. Let's see what happens. Dum, 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 dum. Oh, it made it. It did work. It put lines in where it otherwise hadn't. Whoa. right? So what happens now, this is going off script a little bit, but remember I was talking about the hashtag and how it did a different thing? What happens if I do that? See on line 12, what I've done is I put this extra thing here. Well, let me move these lines the way they've done before. On line 11, right, or yeah, instead where it used to be, like, whatever, I put it line 11 here and I knock that off. What will happen next? What happens? Well, let me run it again and see what happens. Wow, the line came along, but the points disappeared. So somehow this PLT, right, which was imported, right, if I type just plot after it, it'll give the line. If I type scatter after it with the data, then it gives the points. And if I type them both, in other words, I uncomment this, right, then it will do both. Wow. See all these different pieces that are involved here? All these different things that are just a little bit different. But one thing that happened, remember that was a typo-ish, right? On the thing, if I typed on line 5, I said, oh, let me do it on line 5 as I had described previously in the thing. That doesn't work. I had to put it on line 9. So if I go to the lab, let me go one more time, see if I can share the screen here and go to that lab section. Share screen. Here we go, right? What happens in that case? Well, I have to say, well, this line 5 is a typo. I don't want that. That's not cool. I actually have to do it on line 9. But see how there's line 6 and line 7 and things like that, right? Lines through 7. Now that means these lines, these line numbers are going to be a little bit different, right? I have to make some adjustments. Plot.label 7, 8, and 9 is going to be different. And oh boy, this is just too cool. Play, work with it, run, right? And you go further and further and further. You do all these different things, and then you graph and calculate together. Go back to online Python, play with the runs, do these other things. That's what you're trying to do. That's the fun part. So you see how that all goes? That's the goal, everybody. That's what we're trying to achieve. And so if you think about what we're doing in this lab, remember, do not just say, oh, it doesn't work, I give up, right? It's like, oh, I got to put this number there. I have to put that line there. It's a little bit different compared to that. So do it. It's all good. Play. When you're writing up your lab report, write those things up. I had to do this. I had to do that. I have a question here. I have a problem there. I fixed it by doing that. I commented this out. That's where you're learning to play. Okay, that's the lab fun part. Do not be frustrated. If it doesn't work, you're like, ha, didn't work again. Why? What up? Then we have those conversations. Does that make sense? Have that spirit, and don't you worry. Do that way, life will be good. All right, you'll have fun. And that's what we keep trying to do. And we will keep going that way. Do not worry again about right answers and wrong answers nearly as much as you should worry about or think about. Don't even worry about it. Think about and try playing with it, making it work. The first times any of us learn to walk, or even the first time any of us learn to speak, the first time a baby makes a little sound, cuckoo, mama, dada, papa, that kind of thing. Do we say, oh, that's wrong, forget it, stop talking? No, we say, good job, keep going. Yeah. Have that attitude toward all this. Sound good? And we'll talk more again in the future. But remember, talk to your recitation professor. Talk to me. Ask questions, okay? Find out what's going on and keep trying new things. You're going to be in great shape. Sound good? All right. Thank you so much for your time. I really appreciate it. I hope this video has answered most of your questions. And if there are any more questions, feel free to send more along. All right. Have a great time. And thank you again. Really, really appreciate it. Okay. Bye. Thanks. See ya.